Well, hello, fellow hunker-downers. By the way, if you don't watch Leslie Jordan on Instagram, I highly recommend him. He's hilarious. Okay, so anyway, today's lesson, at least the first of two lessons, is on inverse trig functions. Okay, so if you have your unit circle out, and notice I have one here so I can refer to it. But if I asked you to tell me all the places where the cosine of an angle is 1/2, right? I'd have to come around the unit circle and find all the places where the x value, right? Cosine goes with x, is 1/2. So that happens here at pi over 3 or 60 degrees, but it also happens down here at 5 pi over 3 or 300 degrees. Okay, now if I use my calculator, which I just realized I don't have next to me, give me a sec. All right, so if I grab my calculator and I make sure that we are in degrees, which we are, and I do second cosine of 1/2, I get an answer of 60, right? Because the calculator can't tell me two different answers, right? On the unit circle, I can clearly see it happens here and it happens here, but the calculator can only tell me one. So that's called the principal value, all right? And so what the calculator is doing is, if you're doing second tangent or second sine, right? Or if you're doing second cosine, it's particular quadrants that you can look for your answer in. Okay, so all positive answers for tangent and sine will be in the first quadrant, but all negative ones will be in the fourth. Now, here's the only part of this whole lesson that's kind of tricky, is if you, let's say you wanted your answer to be right here, it has to be a negative angle. You have to measure from 0 in the negative direction, okay? Whereas over here for cosine, your answers will be positive in the first quadrant and negative in the second quadrant, but you don't have to worry about any negative angles. Okay, so we're just gonna kind of jump right on in. So this question's asking, because of this notation, right? Because of that notation right there, where is there an angle, right? That's what that says. Where is there an angle that has a cosine value of 1/2? And again, there are two places, but you're only allowed to answer for cosine, right? Think back to this. You're only allowed to answer in the first or the second quadrant. So it has to be the one in the first quadrant. We're gonna say pi over 3. Okay, let's keep going. All right, so this is asking, where is there an angle? That's what this means. Where is there an angle that has a tangent value of 1? Okay, and again, tangent, you can only look in the first and the fourth quadrant. Positive values are going to be up here in the first. So up here in the first quadrant, tangent is the sine over the cosine. It's the y over the x. And if you look right here, if I take this and divide it by this, I get 1. So that particular angle here is pi over 4. Okay, let's keep going. All right, so this is saying, again, let me just kind of translate this for you. Where is there an angle that has a sine value of negative rad 2 over 2? Okay, so again, sine is negative in this quadrant. My answer here is going to be a negative angle. Okay, so if you look right here, do you agree that this is a sine value of negative rad 2 over 2? So if I'm starting here and I'm trying to count this angle, it's negative pi over 4. Okay, you have to start here and get to that location without going around the circle. So you have to go in the negative direction. Okay, here we go. So now I would like you just temporarily go ahead and ignore this part. Okay, ignore that and just tell me what the cosine of pi over 3 is. Okay, and again, if you have to refer to the unit circle, it's right here. The cosine is 1/2. Okay, so now my problem looks like this. Now the question's asking, where is there an angle that has a sine value of 1/2? So again, I'm looking up here. Here's my sine value of 1/2. It's at pi over 6. Okay, let's keep going. All right, ignoring this just temporarily, right? I can easily uncover it. I'm looking for an angle that has a cosine value of 1/2. We've done this exact problem 3 times already. It's right here. Okay, so this is at pi over 3. So now the question is, what is the sine at pi over 3? Well, here's pi over 3. Sine is the y value. It's rad 3 over 2. Okay, let's keep going. ignoring this. This is just saying, what is the y value at pi, right? I'm not finding an angle. I am not restricted at all about which quadrant I can find this answer in because I'm not finding an angle. I have the angle. The angle's pi. So I come over here to pi. The sine value is 0. So let me rewrite this problem now. Okay, so now this question's asking, I need an angle that has a cosine value of 0. All right, and if I'm looking back at this thing, the only places that I can look are somewhere in these two quadrants, right? Somewhere from here to here. So the cosine value of 0 happens right there. So we're looking for an answer of pi over 2. Okay, now this will be my last example. I want to make sure that I cover this one specifically because notice what this is asking. Let me cover this up real quick. This is looking for an angle that has a sine value of 24 over 25. And I'm looking at my unit circle over here and I'm not seeing that anywhere, okay? And the reason this isn't on the unit circle, okay? It doesn't mean that we can't do the problem. It just means I'm gonna have to draw a picture of this angle, okay? So if I want a sine value to be positive, I need to draw this angle in the first quadrant. Okay, so it's an angle. Sine value is opposite over hypotenuse, opposite over hypotenuse. Okay, so again, I'm looking for an angle that has a sine value of 24 over 25. There it is, I found it. That is the angle. Now, this question is asking, what is the tangent of that exact same angle? Well, tangent is opposite over adjacent, so I need to figure out this missing side first. So let me grab my calculator. 25, the hypotenuse squared minus the one leg squared should be the other leg squared, so this is 7. So now I want the tangent of this angle that's opposite over adjacent, that's 24/7. Okay, so there is inverse trig functions. I will be available for office hours by appointment both Wednesday and Thursday, so just shoot me an email. Let me know when you'd like me to be on Zoom and I will be there. Miss you guys. Hope you're doing well. Hope you're safe, healthy. Try to stay home. Bye.